This is the guided note video for satisfying an inequality. Our learning target is I can find points that satisfy a linear inequality. So linear inequalities have a couple of different components that graphing linear equations do not have. The first component is the line type, so we're going to have a dotted or a solid line. And then the second component is the shading. Shading linear inequalities will accurately show which points are included in our solution. Okay, so we'll take a look at how to graph a linear inequality later on. But in order to satisfy an inequality, we are looking for any ordered pair or point that will satisfy the inequality. So it's very possible, given any problem, that we could pick 100 people, and 100 people could have 100 different ordered pairs or 100 different solutions, and they would all be correct. They would all satisfy the inequality. Okay? So having said that, there will be infinitely many ordered pairs that can make an inequality true. So an ordered pair that satisfies an inequality will be on the shaded side of the line because that solution is included, meaning that all ordered pairs on the shaded portion of the line will make the inequality true. Okay, so I'm going to move on. So let's take a look at two examples. So find a point that makes the linear inequalities true. Okay, so taking a look at this one, I will plug in a random point. So I need my y, whatever my y coordinate is, to be less than or equal to 5x plus 5. So let's say I try the point 2, 10. Remember, x always comes before y. And where did I get this point? I just picked it. Okay? There's no rhyme or reason for me picking 210. I'm just taking a point and plugging it in to see if it will satisfy or make my inequality true. So I'll plug in 10 for y is less than or equal to 5. Instead of x, I'm plugging in 2 plus 5. So this used to be y, this used to be x. So now I can simplify, so I don't do anything with the 10. So I get 10 is less than or equal to 5 times 2, which is 10, plus 5. So keep going, so I get 10 is less than or equal to 10 plus 5, which is 15. So now we'll evaluate this. Is 10 less than or equal to 15? Yeah, absolutely, this is true. So that means this point 210 is a solution in my shaded portion. That point, or that solution, that ordered pair, makes the inequality true. So now I'll move on to my next one. So first off, it's in standard form because x and y are on the same side. We have 5x minus y is greater than negative 1. So again, I'll pick another random point. How about 4, 0. Okay, and now I'll just plug this ordered pair, this point, in for my x and my y. So we get 5 times 4 minus 0 is greater than negative 1. 5 times 4 is 20, minus 0, and then I haven't touched this negative 1. So 20 minus 0 is going to be 20, and then negative 1 wasn't touched. So now I'll evaluate. 20 is greater than negative 1. This is true. Okay, so that means this point, 4, 0, will satisfy my inequality. At this point, I would move on to the example video for satisfying an inequality.